All right, we're talking about rates now. We're starting a new chapter, chapter 3. A lot of cool things we're going to be doing with this particular chapter, so make sure you are paying attention. Essential question, how can we use unit rates to compare different things? Okay, so let's take a look. Find your pulse. You can find your pulse through your neck, on your wrist, on your chest, on your arm, other places, but go ahead and find your pulse. That's how many times your heart beats. Count how many times it beats in 1 minute. So take a moment, see if you can do that, and calculate how many beats you have for a minute. Next, Laura counted her beats in 2 minutes, and she got 166 beats in 2 minutes. My question to you is, how can you compare yours to hers? You figured this out, beats in 1 minute. She figured out 166 in 2 minutes. Who has the faster heartbeat or heart rate per minute? That's what we're going to discover in this chapter. So in the previous example, you might have noticed that it's not fair to compare your heart rate in 1 minute and Laura's heart rate in 2 minutes, because obviously she's going to have a lot more in 2 minutes than you had in 1 minute. So we have to compare, kind of like having a common denominator. So the first thing we're talking about is the rate. A rate is a ratio that compares two different units. So here are some examples of rates. 166 beats in 2 minutes, so you can see these two things are different. 240 miles in 4 hours, those two things are different. $5 for 3 pounds, those dollars and pounds are different units. And 8 songs in 2 minutes, different units again. So these are called rates, when you have a ratio or fraction that compares two different units. Now a unit rate is when the denominator is simplified to 1. What do I mean by that? Well, let's take a look. In the previous example, I showed you 240 miles in 4 hours. Well, if I divide both by 4, it ends up being 60 miles in 1 hour. 60 miles per hour. If I took a look at the other one, $5 for 3 pounds of whatever, divide both by 3 to make my denominator a 1, and you can have a unit rate. These are called unit rates, $1.67 per pound. So here are some common unit rates that you'll come across. Miles per hour, when you look on the freeway and you see something that says 65 miles per 1 hour, that's the speed limit. Dollars per pound, you'll find that in grocery stores. Miles per gallon, you'll sometimes see that for commercials about cars and how well they run. So Andrew the other day went on a long bike ride. He biked 32 miles in 4 hours. If he biked at a constant speed, how many miles did he ride in 1 hour? That's the question. So let's take a look. Well, if I have 32 miles in 4 hours and I want to make my denominator a 1, I divide both by 4. If I divide both by 4, I end up with 8 miles in 1 hour. So I know that if Andrew biked 32 miles in 4 hours, and if it was a constant speed, okay, that's the big thing there. He didn't ride real fast, stop, he just constant speed rode, then he'd be riding an average rate of 8 miles per hour. Okay, take a moment to find out the unit rates for the other examples here. Finding the unit rate for 40 miles in 2 hours and 120 miles in 10 hours. So I focus on my denominator. I want that to be 1 hour. In order to get there, I have to divide by 2, so that means I divide the top by 2. So this unit rate would be 20 miles per hour. Over here, I want my denominator one more time to be 1 hour, so I have to divide by 10 to get there, which means I have to divide the top by 10, and I end up with 12 miles per hour. So Jonathan, his mom said, hey, go to the grocery store, buy some juice boxes for yourself for lunch. So he's at the grocery store buying the juice box. He noticed that one juice box cost 75 cents, and a 6-pack of juices cost $3.90. Which is a better deal, and why? So let's take a look. Let's buy a juice box. Well, I've got a rate here, $3 for 6, so I can find the unit rate. I can find out how much it costs per box. So I divided both by 6. I found out it was 65 cents per one box if I were to buy this 6-pack of juice. So if Jonathan needs multiple boxes of juice, so more than one, it'd probably be a better deal to buy the 6-pack because he'd save 10 cents per box. So Vanessa needs to buy some dog food for her pet Ruffles. Get it? Ruffles? Anyway, whatever. When she gets to the store, she sees that there's 3 different bags, so she's not too sure which one to buy. She's got this huge dog food bag, 40 pounds, of $49. There's a 20-pound bag for $23.44, and there's an 8-pound bag for $9.88. Which is the better deal? Is it always best to get the largest bag, or should I spend the least amount of money in one time but get only 8 pounds, or should I go in the middle? Question is, which is the best deal? So in order to compare these things, we can compare by having unit rates. So watch how I did this work. 49 over 40, well, I divide both by 40 to get it down to a unit rate of 1. 23.44 over 20 pounds, I divide by 20. And this last one, 9.88 over 8 pounds, I divide by 8. And these are the 3 unit rates I get. $1.23, $1.17, and $1.24. So therefore, the cheapest for Vanessa to buy would be the 20-pound bag, because that's actually going to be the best price per pound. The last example is Isabel can type 153 words in 3 minutes. At this rate, how many words can she type in 10 minutes? So the good thing to do is to probably take this rate and find a unit rate. So I have 153 words in 3 minutes. I divide both by 3 to make my denominator 1. I do that here. And then I say, okay, so she can type 51 words a minute, times it by 10 minutes, and I end up with 510 words. So therefore, Isabel would be able to type 510 words in 10 minutes. I did that by first finding the unit rate and then multiplying it by the number of minutes. Okay, come to class with questions, and we'll make sure we spend a lot of time on this.